Alright, good evening students. This is your first video for our flipped classroom. We're going to go back and we're going to do a little bit of review from the first 6 weeks before we jump into the next unit. We're going to be talking about linear functions, and you began talking a little bit about functions and relations and domain and range during the first 6 weeks, but I want to make sure we all remember it, we all understand where we're going, and we have that previous knowledge. So today we're on chapter 4.1 and 4.2. Graphing relations and relations and functions. Your essential question: describe a real-world situation using a relation that is not a function. Create a mapping diagram to show why the relation is not a function. We have some vocabulary words from chapter 4.1. Continuous graph and discrete graph. A continuous graph has a continuous line on the graph. The points on the graph are connected by a line or a curve. A discrete graph has only distinct points. They both start with a D, so that's how you kind of remember it in your brain. So a continuous graph and a discrete graph. Now when it comes to graphing relationships, you're going to get word problems and you have to be able to create a graph just from what it says, or you have a graph and you have to describe what that graph represents. This allows you to analyze graphs that you see already prepared in life and know whether they're actually reasonable and match the information given. So some of the keywords you're going to see in your problem solving for graphs are going to be the words horizontal. I'm sorry, not horizontal. It's going to be constant. That's the key word, and that means horizontal. So that means the graph is going across. You'll see the keyword rose steadily, or went up steadily, or went up at a constant rate. That means it's going to slant upward from the bottom left to the top right. You're going to see words like stayed the same. That also means horizontal. So we're going to put that up here together. Stayed the same. You might see the keyword dropped sharply, or decreased, or declined slowly. Any of those are going to be a slant downward. Now, if it said slowly, it's going to be a really shallow slope, meaning it takes longer going from left to right to go downward. It's a more shallow slope or steep or edge. Whereas if it drops sharply, it's going to go down real quick, kind of like a roller coaster, like the drop off on a roller coaster. If you've ever been on the Titan at Six Flags, it drops sharply. So that means it goes down really quickly. Those are going to be your keywords for graphs. Now we're going to look over at the textbook here. These are some examples on page 230 of some graphs. And you can see in graph A, we were horizontal, we stayed the same. We gradually rose, then we had a steady drop off, and then we remained the same. Graph B was steady, then it rose sharply, then it was steady, and then it dropped off quickly. This situation might be somebody's walking. They suddenly speed up to get out of the sun or get out of the rain, and then they're walking, and then they suddenly stop. Okay, so that would be how this graph works. That's all you need to know for this section. Now we're going to move on to section 4.2, relations and functions. Still the same equation, or same essential questions, still the same notes, but we have 4 vocabulary words that we need to add to our notes. So this was the vocabulary for 4.1, and this is going to be our vocabulary for 4.2. Remember, you can always pause the notes and rewind the notes as much as you want. So we've got relation, domain, range, and function. Okay? Remember, a relation is going to be relationships that are represented by a set of ordered pairs. A relationship represented by an ordered pair so that it can be graphed on a coordinate plane. Remember, domain is your x value of a relation. Okay? Your domain is going to be your x value, or the first coordinate. And so if that's the x value, range is going to be your y value of the relation, or the second coordinate. And then a function is a special type of relationship where that each domain is only paired with one range value. Now, two of the domains can share the same range value, but a domain can't have two different ranges. A domain can't be paired with two different ranges, okay? So a special type of relation where each domain is paired with just one range value, okay? And the mapping diagram is the best way to notice this because you can draw arrows. You can also see this on a graph, and we'll talk more about that in just a second when we look at the vertical line test. So a mapping diagram, this shows you that on page 236 that all the x values are with one y value, okay? You can also see it in a graph. Each point has an ordered pair, or we can see it in a table. First place got 10 points, second place got 8 points. This shows you relations, okay? Each one of these can be represented by an ordered pair. Now you take that a little further and you have where each domain is paired with one relation. So this right here, 2a, is a function, okay? Because each number in the first column is paired with one number in the second column. In other words, they don't have two arrows coming off of one number, okay? So the arrows don't start. It doesn't have, one number doesn't have two arrows starting from it. But it's still a function because even though this range has two domains coming from it, that's okay, all right? And if you were to give the domain and range of this map right here, you would say your domain is 6, 5, 2, and 1. And then you say your range would be -4, -1, 0. So let's put that in our notes. I'm going to put a picture of this right here in our notes, so you want to draw it. And I'm just going to cut and paste. Here we go. And if I gave the domain and range of this, the domain, remember we use our little bracket symbols, would be 6, 5, 2, 1. And then our range, using our little bracket symbols, would be -4, -1, 0. Use your little brackets. Okay? And this is an example of a function because each domain matches with, hello, I'm having trouble spelling here, matches with one range value. Okay, even though two of them, the 5 and the 1, are both going to 0, it's still a function. Okay. Now remember, oh my goodness, I hope that sound didn't come in y'all's ears as loud as it did mine. Alrighty. Now another way is you could look at a graph to see if it's a function and if it was a graph. Okay, so when you have a graph, I've turned to page 243, you can also do what's called a vertical line test. By doing a vertical line test, what's happening is you're going through the graph with a vertical line, and if that vertical line passes through 2 points on the graph, then that means you have a domain or an x value that has two different range values or two different y values. Therefore, it is not a function. Okay? A circle is not a function because if I draw a vertical line anywhere on this graph, I'm going to hit the circle in more than one spot. Okay? Number 2 is a parabola, and it does pass the vertical line test because anytime I draw a line, it's only going to go through it once. So if it looks like an N or a U, it's good to go. But if it looks like a C or a backwards C, it's not a function because if it can't pass the vertical line test. For example, right here where x equals 2, we're saying that y equals 2 and y equals negative 2, and that's not possible, okay, for it to be a function. It's still a relation, but it's not a function. Because remember, a relation just needs ordered pairs, and we got ordered pairs. But to be a function, each x value has to have one y value, okay? So that's what you're doing there. So in your assignment, you're going to be identifying whether it's a relation or a function or both, and you're also going to be identifying the domain and range. Okay, don't let the words domain and range confuse you. Domain, list all the x's. Range, list all the y's. And remember, you don't have to write them all out. If it's a whole long list of numbers, you can say x is greater than or less than a certain set of numbers, and put them as they're between those numbers. Okay, function notation is what that's called. All right, enjoy, have a good evening, and I will see you tomorrow in class to complete our assignment.